folks. Missed you today. Hope you had a good day in math class. So I wanted to walk through the practice test in case you didn't have a chance to get all your questions answered in class. And so you can revisit this for additional review, practice, etc. Cool. Let's do this. All right. Let's do some math. So we are looking at the integrated math one, that's the class you're in, functions test, and this is the practice one. So the idea for a practice test is it gives you a chance to see, okay, if this were the test, how would it go right now? And then you can adjust and calibrate and move forward and hopefully do better on the first time you take the real one. Than you do on this one. So the whole point of this is to figure out where you're going to make your mistakes so you make them here. I'm also going to then post this after the fact as the key. So I'm going to make a note that that's the key. And let's dive in. Yeah, put the date and period. I'm not going to put it on the key. All right. So first says, use the graph at right to answer questions 1 and 2. Okay. So question 1 says, list the points on the graph as an ordered pair. First things first, an ordered pair is just when we have our x value and our y value for a given coordinate. It's always x, then y, just like in the alphabet. And x is going to be our horizontal axis. I encourage you to always label your axes, even if you think you don't need to, because it's very, very simple and easy to make a mistake, even on a simple and easy content for you. So just do yourself a favor, write it down. You're a lot less likely to get those mixed up now. Okay, so we're going to list each of these points as an ordered pair. So our first one, point A, I'm noticing that it goes from the origin to the right 4, and then it doesn't go up or down at all. So the x value of that point is 4, and the y value is going to be 0, because from this point, I don't go up or down at all. I'm just right there as soon as I move to the right by 4. So that's my x is 4 and my y is 0. Now we're going to do it again. So for point B, I always start at the origin. And point B is 3 units to the right and 1 unit up. So the x component here, the side to side, is 3 to the right. So that's positive. And then from the axis, I had to go up by 1. So that's our y value. Okay. Last but not least, C. C is down here. And to get there from the origin, we're always starting at the origin. I have to go 1 to the left. So that's going to be our -1 for our x. And then from this point, I have to go all the way down to -4. So our x value is -1 and our y value is -4. Okay. So hopefully you've got some practice with that. If you need more practice with that, check out in IXL plotting points on a coordinate plane. That'll really help with that skill. Now we're going to go backwards. Part 2 says, plot the following points on the graph at right and label with the correct letter. Okay, I'm going to underline this, and label with the correct letter. How many times do you think the other Math 1 teachers, have seen points in exactly the right spot with no letter? Make sure you read and follow all of the directions every time. So, D, 0, -4. So from here, my x coordinate, I'm going to label these x and y, my x coordinate is 0. So I'm not going to go right or left at all. And then my y coordinate is -4. So I'm going to go all the way down here to -4. I'll plot a point there, and I'll say that this is D. Now I'm going to do the same thing with E. I'll label my x and y. Again, you don't have to label your coordinates, but it's not a terrible plan. And we've got from the origin, -2 is our x. I'm going to go left 2. And then +4 is our y, so I'm going to go up 4. And right here is going to be point E. Okay, cool. Part 1 down. Now, let's dive in a little bit to some functions. Okay, question 3. Evaluate the functions for the given value of x. Show all work. Okay, this is key. I know some of you can do this in your head, and that's awesome, but you will get to a point where you can't, and you want to build the muscles now of writing it out, keeping it organized, showing your steps. Because when you get to the point where you need that, if you haven't practiced it, it's not going to be there. And I say this as a person with experience doing that. Okay, so right here, part A, f of x equals x plus 2. So then we have f of 5. Remember that anytime we're replacing the x with a number, that means that this number is our new input. And if we replaced it right here, we also have to replace it here. Now, personally, I will always suggest that you start by rewriting the function with parentheses in the spot where the x was. Then you can fill in whatever number is in these parentheses and go from there. In this case, the parentheses go away right away because there's nothing happening inside them. There's no negatives. There's no exponents on these parentheses. There's not a whole lot going on. But again, as it gets more complex, those parentheses are going to answer a lot of questions. All right, so then, like I said, there's nothing going on inside the parentheses. It's just a constant, just a whole number, or just a number. There's no exponents. There's nothing being multiplied on the outside. So I'm just going to rewrite it as 5 plus 2. And then I get to 7. So f of 5 for this function f, if this is how f is defined, is equal to 7. Great. Same thing. This -3 is our input. I'm going to rewrite the function and put parentheses where the x was. Now I know that my input is -3. So I'm going to put that inside the parentheses. Whatever replaces the x that was here is what replaces all the other x's in the function. Now, anytime I have a number next to parentheses like that, it means multiply. Since these parentheses just contain a constant, I just go straight to the multiplication. There's no other operations inside the parentheses to deal with. A positive times a negative is a negative, and 5 times 3 is 15. So g of -3 is -15. When the input is -3, the output is -15. All right. Moving right along. Basically the same idea here, slightly more involved functions. So I'm going to approach it the exact same way. I'm going to rewrite my function. So f of x is now 4x minus 3. I'm going to rewrite it where I replace the x with parentheses. And here, this is asking for f of -2. So now I'm going to take every place I see an x in the original, I replace it with parentheses, -2 goes inside those parentheses. Now I simplify. You could absolutely type this in a calculator, especially to double check. But let's walk through it. So a positive times a negative is a negative. And then 4 times 2 is 8. So this is -8 minus 3. Be careful with your addition and subtraction when you've got negative numbers. -8 minus 3 is -11. So if you think about your number line, if here's 0, here's -8. If we're at -8 and we're going 3 more to the left, right? Subtraction goes away, goes to the left, right? That's going to take us -9, -10, -11. And so that's how that subtraction is working. So our final answer here then is that f of -2 is equal to negative 11. When the input is negative 2, the output is negative 11. Same thing over here, g of x is equal to 10x plus 7. I'm going to rewrite the function and replace the spot where x is with parentheses. Now it's telling me the input is positive 3, so that's what I'm going to put in the place of all the x's. And then I simplify. So 10 times 3 is 30. 30 plus 7 is 37. So g of 3 in this case is 37. So when 3 is our input, 37 is our output. Okay. Onward and upward. Question 5. So here's where graph functions come into play. The function f of x is graphed at right. So this is f of x. Find f of 1. So we have a number inside the parentheses. This is an input. That also means it's an x value. So because the number is inside the parentheses, it's an input. And for our graphing purposes, that means it's an x value. So we're going to find on our x-axis where x is equal to positive 1. And that's right here. Now, what's a little bit funky is this graph curve, this I think it's a cubic function. This cubic function, it doesn't go through exactly this spot. So what we're looking for here is when x is negative 1 on this blue line. So what I like to do is draw a line. So since I have my x value, I'm going to draw a vertical line. So these are all the places, and if I put arrows on the end, it would go to infinity. All the places where x is equal to 1. And the place where it crosses my graph is right here. This is the point I'm looking for. So if this is my x value, my input, what I'm looking for now is my output or my y value. So this is where x is equal to 1 on the function. And if I go to the left, this negative 2 is going to be my y value. It's going to be my output. And that's that. So one more time. We're looking for when x is 1. And then if you want to go a little bit more efficiently, you can just go up or down until you bump into the graph. Boom. And then go towards the y-axis, and there is your y value, because this point has a coordinate of 1, negative 2. Now, does the graph at right represent a function or not a function? Circle 1 and explain your choice. Don't forget to actually explain when asked. Okay, so I'll tell you, this is a function. The way I know is, I'm going to get rid of that, and I'm going to borrow this line. All right, the definition of a function is that each input has at most one output. And so if we want to think about this in terms of x and y, you could think of this as each x value has at most, so could be less than this, could be 0, but at most one y value. This allows it to be a function because we have consistent outputs. Thinking about that soda machine, right? You press the same button, you should get the same soda. If you don't get the same soda each time you press the same button, the machine's not functioning properly. It's not a function. A visual way to look at this is something called the vertical line test. Now, that's not a great explanation. I don't even know if it counts as explaining why, but it's a way to check. It's a tool to check if each input has at most one output. So what we're going to do is we're going to take this orange highlight line. We're going to pretend like it's perfectly straight. And as I go from left to right, and I'm keeping it vertical, there's never a time when I'm crossing that blue curve more than once at the same time. And so if we were thinking about this horizontally, like right here, this horizontal line is crossing our curve 1, 2, 3 times at the same time. So this wouldn't pass the horizontal line test, but we're not interested in that in Math 1. We're interested in the vertical line test. And it does, in fact, pass the vertical line test. There's never a place where I'm crossing through that blue graph more than once at a time. Okay, good. Functions. Woo. Couple more. Question 7. If f of x is equal to 3x plus 2, find x when f of x equals 20. I want you to really pay attention to that find x. If it's asking us to find x, then right away, we should know that 20 is not x. 20 is y. 20 is the output. We are searching for the input. So we want to know what value of x will produce an output of 20. So to find that, the way we're going to set this up, the ideal way to set this up would be to say 3x plus 2. So that is this part, the 3x plus 2, is equal to, oops, sorry, turn that around a little bit, is equal to the output of 20. And so that is this 20 right here. So we set the function rule equal to the output. Now we can use legal moves to isolate x, and that will give us our input. So right here, there's minus 2, or excuse me, there's a plus 2. We always want to get rid of plus and minus first. Basically, we're reversing PEMDAS. So I'm going to subtract 2 from both sides. And technically, you could divide everything by 3 first, but that's going to be more annoying to work with. That's why I want to subtract 2 first. I'm subtracting 2 because that's the opposite of adding 2. So these are going to cancel each other out. They're opposite operations. So now I've got 3x is equal to 20 minus 2, which is 18. Right here, the coefficient on x is 3. So the coefficient is the number that's just to the left of the variable, and it's telling us this number times this variable. So the opposite of multiplication is division. I'm going to divide both sides by 3. Anything divided by itself is 1. So we want to get 1 positive x. I'm going to write that. And 18 divided by 3 is 6. Now, totally fine if you want to leave it like that without the 1 there. I don't mind if you have the 1. I don't mind if you don't have the 1. Just recognize if there's an x here, that means there is 1 x. And that's how we know we're done solving. We have 1 positive of the variable. So this is our x value when the output is 20. All right. Last but not least, we have our graph again. The function g of x is graphed at right. So now this is g of x. Find the value or values, notice that s, of x when g of x is equal to -1. Okay, so again, we're finding our x, our input, which means -1 is our output or our y value. So this is similar to what we did before, but now we're being given our y value. So I'm going to label my axes. Here's x and y. And then I'm going to look for where y is equal to -1. So starting at the origin, going down 1. So y is equal to -1 right there. I'm going to draw a line straight through it. And now, I'm going to note there's a spot that my horizontal line for the y value, there's a spot right here where it crosses the graph. It crosses the graph again right here, and it crosses for a third time right here. So there are 3 x values. So I'm going to put some commas here because there's 3 values. Would that be an or an and? I think it's going to be an or. There's 3 values that satisfy this output of -1. So the first one, if I look right here, that appears to have an x value someplace between -1 and -2, probably a little closer to -1. So I'm going to call that like -1.2. Realistically, anything that's reasonable for this value is going to be correct. We're not robots. We don't have super fine detail on this graph. What I need you to communicate is, okay, it's past the -1, it's going towards -2, but it's somewhere between those. As long as your number does that, you're good. Same thing here. This next point, the x value seems to be maybe a little less than half. So I'm going to say 0.4. That's a little less than half. Could it be 0.38? Absolutely. Could it be 0.42? Absolutely. As long as it's in the ballpark, we're good. And then last but not least, right here, it's almost all the way to 2 on the x-axis, but not quite. So I'm going to call that 1.8. And there's my 3 values, right? This horizontal line crossed the blue graph 3 times. So I found the x values for each of those intersections, and those are my possible x values, my possible inputs that produce an output of -1. I hope this is helpful. Happy studying. See you next time.